Hello. Okay, welcome if you're here, guys. Hopefully you can hear me okay. Feel free to write in the chat as well to let me know you can hear me. We're going to be looking at partial fractions today. Lovely, excellent. Okay, so there's people ready and waiting. Lovely, cool. Right, I hope you're all keeping well. Bit of a strange situation still, so obviously there's a lot online and we're running these sessions to help you out as well. We had the first session for maths last week. Excellent, good to hear that you can hear me. It was quite straightforward last week. We flew through it. I had some brilliant answers coming in as we worked through it, and actually we ended up getting through the content really quickly. What we've got planned today is actually quite difficult, and so should be quite challenging for everyone really. Lovely, if you're in year 11, 12 or 13, this might be some use to you. This is mostly pitched at the year 13 maths. So it will be a bit of a recap at some of the year 12 stuff, but it will be challenging even for year 13. So even if you're looking at this as a bit of an insight of what's to come, that's brilliant as well. Okay, so we're going to look at partial fractions. And as I said, a lot of this is typically covered in year 13. So I'm going to share my PowerPoint with you now. Feel free to answer and ask questions throughout, guys. That would be brilliant. And as I said, we'll work through solidly through the PowerPoint, and do stop me at any point if you're struggling with the content, because it'd be useful to know anything we need to go over. Brilliant. Hello, welcome. Right, I'm going to share my screen with you now. Okay, right, it's this one. So if you guys can let me know if you can see that. I'm going to make that full screen and hopefully that'll be nice and clear for you. Can we all see my PowerPoint there? I think I'll be kind of floating up in the corner somewhere. Hopefully that's good. Can we all see that? Brilliant. Okay, so the live session should last about an hour. We're going to go through some questions to start with, and then towards the end, I'm going to say a little bit about Snap Revise and what we're going to be doing over the next few weeks, months, and so on. But to start with, we're going to work through partial fractions, which, as I said, is a really big year 13 topic. Great, right. It looks like everyone can see my PowerPoint nice and clearly. I'm going to flip my laptop round so that I can write on the screen. So hopefully that's good. Brilliant. Okay, well, we'll get started then. So here we go. Oh, and before I forget as well, something else to mention. There is going to be a coupon code for everyone at the end. So if you stay tuned, I'm going to put that voucher code up at the end, and it will be offering a discount for Snap Revise. So stay tuned and follow along. If you've got a bit of pen and paper, you've got your calculator with you, work alongside this. That would be brilliant. And here we go. I think we'll get started. So this question is asking us to express this algebraic fraction in partial fractions. Now, as I said, this is something we cover typically in year 13, but we may recognize algebraic fractions from GCSE, and we might be more kind of familiar with putting it in that form as opposed to working back. Okay, so what we're going to do is, when it asks for us to write it in partial fractions, what we need to do is recognize that it wants us to write it in the following way. So we want to write this as something over x minus 1. Now, if you're in year 12 or 13 and you've spotted this topic, you've done this topic, you might recognize it as something that feels, you know, like we're going back to algebra and it seems a bit out of place. This actually becomes very important when we go on to calculus and integration, because something like this is often the first part of a bigger question. Okay, so what we need to do is be careful here, because this is really important that we can kind of write fractions back in this form, and it's not always as simple as it looks. So well done if you've already had a go at this, that's superb. I am going to talk through the method And the way to do this is basically recognize that this is kind of, to go from here, from the kind of right-hand side to the left, you would make a common denominator of this. And as a result, what we would have is we would have 2x minus 1, the numerator we're trying to achieve, must be equal to a lots of 2x minus 3 plus b lots of x minus 1. Okay, and some people struggle with that step, so I'm just going to explain where that's come from. But basically, remember that to make it a common denominator, you would have a times 2x minus 3 over x minus 1, which it was originally over, and 2x minus 3. So what we've done essentially, if I change pen just to indicate, is we've just times by 1 in a clever way to make it an equivalent fraction with a common denominator. And likewise, the b term, the b part rather, needs another x minus 1 to give that common denominator so that we get it over the same thing. Okay, so do ask questions if you're unsure, but some of you, it looks like you're familiar with this stuff, which is brilliant. So what we do here is now we can start solving this. So let's have a little look. So the way, by looking just at the numerators, what we can do is we can actually use kind of clever substitutions. So I could let x equal, and if I let x equal 3 over 2, then what I'm going to get is I'm going to find, if I sub that into both sides, I'm going to get 3 minus 1 is equal to, now a times, if I sub 3 over 2 in, that whole bracket is going to go to 0. So that kind of is a clever technique to use that substitution. And then if I sub 3 over 2 in here, I get b as equal to a half. So sorry, not b is equal to a half b. Okay, so I end up with 2 equaling to half b. So then I know b equals 4. And very well done if you already got that, because I know some people have already put this in the chat. So yeah, so be very careful with this, because although it might seem straightforward, it's still very easy to make a mistake. And if anyone could suggest another useful substitution, what else could we plug in for x to make this work well? Feel free to message in the chat. Some people may well have already done that. So we could also let x equal what? To kind of tidy this problem up. Super, brilliant. Yeah, let x equal 1. And then what we'd get on the left-hand side, 2 times 1 minus 1. So you're going to get 1 is equal to, and then here we're going to get minus a, because 2 times 1, 2 minus 3 is minus 1, minus a, and then b, 1 minus 1 is 0. So we just get that. So if minus a equals 1, then that tells us that a is equal to minus 1, and we're done. So just remember that your final mark, you'll just make sure you plug it back in, is to sort of show that this is written as minus 1 over x minus 1 plus 4 over 2x minus 3. And this is a really crucial skill. It makes this fraction a lot more user-friendly in terms of the calculus. So very well done if you got that. These questions are going to get a little bit trickier, so we'll move on. As I said, keep asking any questions as we go if you're unsure about anything. Right, let's have a look at this one. This one's a good one to look at. So what we've got here is an interesting situation, because this is actually what we would call an improper fraction. We don't typically, oh, sorry, my video's just disappeared, guys. I don't quite know what's happened there. Can you all still hear me okay? Excellent. I can see the suggestions coming in. Can everybody still hear me okay? Oh, and I'm back. Excellent. Right. So what we're going to do is, yes, well spotted. Someone mentioned that it's a difference of 2 squares in the denominator, and that is going to be really useful in a minute. But the first thing I want to highlight to all of you here is that this is an improper fraction because the order or degree of the polynomial on the top is greater than or equal to that of the bottom. so of the denominator. So because it's a quadratic on the top over a quadratic, this is what we'd refer to as an improper fraction, an improper algebraic fraction. And actually, some people look at this and go, okay, but it's +4 and -4. So if that number had been bigger or smaller, would it still be improper? It's nothing to do with the coefficient. This number could be less than this one. It's all to do with the powers. And I'm going to show you how we can manipulate this to really show that it's improper. And some people are suggesting algebraic long division. But for this kind of question, I'm going to show you a bit of a shortcut, because actually this doesn't lend itself very well to doing polynomial division. So I'm going to show you a kind of way to get around this, and it's really worth paying attention. It's a nice little method here. So what we can do is we can basically say, if I know it's improper, it's perhaps some multiple of the bottom and then shifted by an amount. Okay, so I'm going to suggest that we rewrite this. We rewrite 9 plus 4x squared over 9 minus 4x squared as 18 minus 9 minus 4x squared over 9 minus 4x squared. And you might be thinking, how on earth has he just made that up? How has he just known that he can use that? What we can essentially say is that if I can write it as a shift of as a multiple of the denominator, but shifted, then I can actually take out a whole number part, okay? Because what this really is on the top is, if I think of what I've got on the bottom, I've got 9 minus 4x squared. If I say, right, it's top heavy, it's improper, I've got 9 minus 4x squared over 9 minus 4x squared, that would be equal to 1. How far away am I in terms of numbers from having that on the numerator? Well, if I want 9 plus 4x squared and I do 18 minus that value, what I basically get is that this is 18 over 9 minus 4x squared minus 9 minus 4x squared over 9 minus 4x squared, which is 1. Okay. So this is tough. This is a big jump up from what we just did in one question. Suddenly it looks a lot trickier, and I really want to make sure that this is clear for everybody, because what we get left with here then is that this is the same as 18 over 9 minus 4x squared minus 1. Okay, and so straight away it is a really useful technique, but it is hard to spot sometimes. What am I doing there? This minus 1 straight away is the value of a. Okay, so this technique is actually, sometimes it's a bit easier than this depending on the question, but what you actually should be looking for to save you doing polynomial division of questions that you know are going to have kind of this simple part coming out, is to basically compare to the denominator and say, right, it's improper, so there's got to be some multiple of the denominator shifted by an amount. So if we spot that, if we could go, right, how can I use the 9 minus 4x squared and then see how far away I am, then I can resplit that in terms of the numerator to get that whole part coming out without using polynomial division. So hopefully that's clear what I've done there. Feel free to ask any questions, as I said though, guys, because now we're at the stage where actually it's not much more difficult than the previous question. We're just dealing with this. And as someone suggested earlier, we can actually use difference of two squares to factorize the bottom, the denominator, and just deal with that little partial fraction scenario going on there. Okay, brilliant. So what I can do is I can say for this bit here, whoops, do this nice and neatly, is I can say, right, 18 over 9 minus 4x squared. And someone spotted that this can factorize as a difference of two squares to 3 minus 2x, 3 plus 2x. And that is a GCSE style factorizing, but it was a tricky one. It wasn't just a straightforward x squared minus 144 or something like that. So still be careful with this. And this will go to a over 3 minus 2x plus b over, actually, do you know what? Let's stick with what they've used in the actual question. They've said we want something b over 3 plus 2x, and then they've called it c over 3 minus 2x. Okay. Yes, absolutely. So just a little question coming in there. Where did the 18 come from? So what I did was, because this was the hard bit of the question, was compared to the denominator and said, right, if I had 9 minus 4x squared over 9 minus 4x squared, that would be that would just be minus 1. That would just be positive 1. And if I had minus 9 minus 4x squared over 9 minus 4x squared, that would be negative 1. Now, my actual question, I wanted 9 plus 4x squared on the numerator, okay? So if I multiply this denominator by minus 1, I'd get minus 9 plus 4x squared. So I'm out by 18. Because if I have 18 minus 9 minus 4x squared, that would tidy up to the thing I want. So I'm manipulating the denominator in order to get the numerator that I desire in terms of multiples of that denominator. Okay, I hope that makes a bit more sense, but essentially I'm using the denominator to try and get out a part that, you know, will tidy up quite nicely. Now let's go through from here, because this is actually the same technique as earlier. So what I can do is say, well, let's look at what's going to happen with the numerators. 18 is equal to b, lots of 3 minus 2x, and c, lots of 3 plus 2x. And then I could quite cleverly sub in different values for here. So if we sub in, say, for example, 3 over 2 or minus 3 over 2 for x, and then what we're going to get, there's no x's on this side, but those brackets are each going to go to 0. And so I'm going to come out with a value that b is equal to 3 and c is equal to 3, which I think somebody suggested earlier. Well done if you got that. So basically, in answer to the whole question, we end up with minus 1 plus 3 over 3 plus 2x minus 3 over 3 minus 2x. And then I've got the answer in the form that it wanted in partial fractions. So what I did was I let x equal 3 over 2, and then I let x equal minus 3 over 2, subbed it in and solved for b and c. Right, good point. Somebody's just asked about this bit here, because I never actually mentioned that. That's a really super question, because I've just said use those values, and in the domain of the question it said x can't be that, and I'm really pleased you've picked up on that, because I forget this every time I teach this. People do ask, hang on, the question just told me not to do that. That is not a valid final answer for x. So I do really want to clarify this. You're absolutely right. In terms of the actual partial fractions, x can't be that. And the reason x can't be 3 over 2 or minus 3 over 2 is because then we'd have a denominator of 0, which you can't divide by 0. It would say math error on your calculator. It's an issue. But you can let it equal 3 over 2 and minus 3 over 2 as a mechanism for solving this linear equation. So very well spotted, in that x can't be that value because the whole function would have a problem, but we weren't solving the whole function at this stage. We were just trying to put values in to find b and c. You could actually let x equal anything and still solve it. I chose those because I thought that they made it the simplest to solve. But very well spotted. I've just seen that comment in the chat, and I think that was super. That was really good attention to detail. Does that clarify it? So you're absolutely right. X can't be equal to minus 3 over 2 or 3 over 2, but we can use it at this stage to solve the linear equation and find values for b and c. The value of a we found earlier is minus 1. Okay, so a was minus 1, b was 3, and c was sorry, that should be a plus, shouldn't it? and c was 3. And we found that from the manipulation at the start of using improper fractions and dealing with that. A is equal to -1, absolutely. Brilliant, right, super. So that was a really good question to go through carefully, because actually you can see, it's a 4-mark question, but it's suddenly a big jump up on what we've just done, and also could still be just the start of a bigger question. Right, super. So we're going to carry on now to look at something that is very much a year 13 idea, and that is that same question we've just dealt with, but we're going to integrate it with respect to x, and it's bounded integration. So this could be to find like the area under that graph between 1 and -1 for x. But this is bounded integration. So this is calculus. This is a topic you meet in year 12, but gets very much extended in year 13. And so there'll be some ideas that if you haven't done this before might be brand new to you, but I'm just going to walk it through, given that we've already solved kind of the previous part of this question. So this is part B. Okay, so if we're asked to integrate between -1 and 1, 9 plus 4x squared over 9 minus 4x squared. This is precisely why we need to know how to do partial fractions, because it's so much easier to deal with the integral of the function we just tidied up. So because I know that that fraction can equivalently now be written as -1 plus 3 over 3 plus 2x plus 3 over 3 minus 2x. This is a lot easier to integrate. Okay, so well done if you've gone ahead and you've had a go at this. But integration is a topic you start to see in year 12 and you build on in year 13. So this process of integration, what we're going to get, we use square brackets to denote once the integration has taken place, but we also still need to put the bounds in. So -1 is going to integrate to -x. This is a tricky integration by recognition. We'll go to 3 over 2 times the natural log ln of 3 plus 2x. And then it's going to be, and we're going to minus 3 over 2 times the natural log of 3 minus 2x. So the integration has taken place by this, this stage, but we also need to sub in 1 and -1. Okay, so now we sub these values in. I'm just going to pause at this point to say that your calculator will solve this. The classwares and some of the newer calculators do bounded integration. So you actually could type this question in at the start and get the answer. And this has been a big change in the A-level since the kind of reform of the A-level in 2017, that the calculator will evaluate this and there's not a problem with using it. But this is a 5-mark question. So you would be expected to show your work in, and the calculator is only really handy for a final checkpoint. Okay, so absolutely, you can sub this bounded integral in and evaluate the number at the end, but it won't give it in exact form. It will give it as a decimal. So in the pure papers, they often want you to give it exactly. And so you'd have to really work through the method anyway, and then just sense check your answer is the right sort of rounded decimal at the end. Okay, so we'll work through this because we're kind of getting there now. So what we do is we sub 1 in as x, and then we sub -1 in as x, and we take it away from each other. Okay, and I'm going to leave it all exactly, and then we go back to normal brackets for this stage. So we put 1 in, so -1 plus 3 over 2 ln of 3 plus 2 times 1, so 5. That would be 1. Then I'm going to minus -1 subbed in, so -1. And then this would be 1. And for anyone who's done log rules, logarithms, they'll know that ln of 1 is 0. So those bits are going to start to disappear, and this will tidy up quite nicely. 3 over 2 ln of, and that will be 5. Okay, and so this whole thing, if we do it carefully and exactly, I believe that this one should be looking to tidy up. So the -1 and the -1. So -2 plus, and it's just going to be 3 lots of the natural log of 5. Okay, so that's your exact answer. And if you type that into a calculator, it should be the same value that you get if you just did the integration from scratch at the start. So don't forget that the calculator is handy and you're allowed it for your A-levels to work out this, but really only to kind of check. You've still got to show a method. Okay, so again, this was part B of a question with partial fractions, but hopefully it's given you a sort of an insight into how tricky these questions can become, starting from something that looked very algebraic to a much bigger question. So well done. Hopefully you kind of follow that, and excellent if you did get that answer. Right, let's move on. So I've got another question here. So this one is just a kind of straightforward to start with, equate the bits, do the partial fractions. Yes, so this is, again, as I said, this is a year 13 topic. Some schools do start this in year 12. Towards the end of year 12, they start this partial fractions algebra. But the actual calculus and the integration, like the question we just did, that's very much towards the end of the course. So this requires kind of a lot of different skills coming together here. But the bit before was very much the earlier partial fractions idea. So this question here, again, is still that algebraic approach of dealing with partial fractions. The difference with this one is what we call a repeated factor. And what we have to do with this is we can't just write it as something over 1 minus 2x all squared. That's not actually simplified it. You have to consider a repeated factor. And then we still look to find the values of the numerators, kind of coefficients or constants that make that work. Okay, so for this one, we're going to do a similar thing again. And again, if we look at equating the numerators, 3x minus 1 is going to need to be equal to a multiplied by 1 minus 2x plus b. Now, I just want to pause here to check that we can all follow why that's the case, because I know a lot of students struggle with this step when there's a repeated factor. We've only actually, the only fraction we've got to change to get that common denominator is this one. Okay, this needs to be times by another 1 minus 2x over 1 minus 2x. So please let me know if that's clear or if it's not clear, because I know that this is a point where a lot of people struggle and they felt really confident with the simple ones up till here, and then suddenly it's kind of thrown them again. So equating the numerators, we're looking again at, can we sub things in to find A? Can we sub things in to find B? I'm going to say a useful thing to sub in for A would be what? Lovely, good. And thank you for the feedback, guys. The kind of engagement with this is really good for me to know, if we're going too quickly or too slowly. And some people are flying through and getting answers, which is great. What would I sub in for X here to perhaps find one of the values? Yes, excellent. So if we sub in, if we let X equal a half, and again, we might think, is this telling me like I can't? It can't equal a half in the final part of the question, but we can use that as a technique for equating and finding A and B. So by subbing X in to this kind of identity here, 3 lots of a half minus 1 has got to be equal to, now the reason I've chosen a half is because this whole bit goes to 0. So 0 lots of A, so it just equals to B. So what I've done is I found that 3 over 2 minus 1 equals B. So B is equal to a half. Okay. Now, this is the bit we might struggle with, because we might think, well, what do I sub in to find A? Because I've subbed the thing in. So in order to find A, we've got to be really careful. You could sub in any value of X now that we know B, or we could do something a bit easier than that and kind of compare coefficients. So if I put B in and I look at what I've got overall, I've got 3x minus 1 is equal to A minus 2ax plus B, which is a half. Okay, so from here, I know that the x parts is this bit here, and the number parts is this bit here. So A plus 1/2 needs to be equal to the minus 1, and minus 2a needs to be equal to 3. So I can solve either of them to find A. Okay, so that would mean that A was equal to 3/2. And if I check it in here, that would still, minus 3/2. And if I check it in here, that's why it helps, because you spot things like that. A is equal to minus 3/2. Is that clear for everyone? Good. And some people have found kind of careful ways of doing this and manipulating to find A and B. But it's just a case of subbing back in what you know, then finding the other bit. Okay, you can plug X in for any value, because it's kind of the two sides are identically equal, but we're essentially trying to find A and B. Okay, so what we end up with for this question is that it can be written as, f of X can be written as, and this is another thing we've got to do carefully. A was minus 3/2, so that's minus 3 over 2 lots of 1 minus 2x. That 2 can kind of just get absorbed into the denominator there. Plus 1 over 2 lots of 1 minus 2x squared. Okay. So I'm hoping that's clear. I'm hoping you can all see that and hear that clearly, and it makes sense to you. But feel free to ask or check any bits we're not sure with. Okay, so and that's another little thing I think we always come across when A or B comes out as a fraction. Students are often inclined to write it as a fraction in a fraction, which is horrible, because actually all you need to do is kind of combine the denominators. Yeah, no worries. So this, I mean, we're getting through the content. We've got one other bit that's quite tricky, so I wanted to make sure that this is just very clear. But I just want to really clarify this, because minus 3/2 and a half, if you think about, if I've got a half divided by 5, you can kind of combine the denominators, and that's just a tenth. And I know that seems basic, but actually, I know from experience, this is a place people mess up in the A-level when they're trying to tidy calculations up. Brilliant. Right. Let's carry on. So the next part, now this again is another big extension in year 13 of this topic. This is the binomial expansion now, using powers that are like negative of the bracket. So in year 12, you do a bit of binomial expansion, but it's all nice, positive integer powers. So like expand 1 plus x to the power of 8. And we use the binomial expansion for that. But this is a year 13 binomial expansion question. So what we're going to do is firstly start by writing what we just found in part A. And I suppose this is a hence or otherwise question. So you would get follow through marks if you got A and B slightly wrong, but you still have to understand what to do with this method. So what we'd do here is remind ourselves that we just found out that this is the same as minus 3/2. Yes, so the year 13 binomial expansion is a big step up. So that's fine. We'll look at this very carefully. And I'm just going to rewrite this as 1 minus 2x to the minus 1 plus, and this was a half of 1 minus 2x to the minus 2. Is everyone happy that I can do that? So I've used my answer to part A, but instead of just putting them as fractions again, I've put them as brackets raised to negative powers. Yeah, they do get quite involved. I believe a lot of the time you're given the formula for this in the formula book or in the front of the paper or whatever, but we will go through it carefully because there's two key parts we need to do carefully here. So let's have a little look. So the first one, I'm going to factor out -3/2. Okay, I'm just going to take that out of whatever I'm doing. And then over here, I'm going to factor out 1/2 in a minute. Now, the binomial expansion, using the formula that you'll be given from the formula book and so on, when it's in the form like 1 plus ax, the 1 is the first part of the expansion. And then what we're going to do is we're going to use the powers, and they're going to gradually kind of go more and more negative. And then we're going to times that by the other part of the bracket, -2x. And I would use a lot of brackets here carefully to make sure that I'm careful with the negative signs, okay? And it says up to the term and including the term x cubed, okay? So let's have a little look. So then the next bit would be -1 -2 over 2 factorial, and then that would be times by -2x, and that's the squared term. And then the next one be -1 -2 -3. Okay, cool. I've just spotted that question, which I'll try to come back to in a second. So this bit over here is going to be the 1/2 times the other bracket, which I'll deal with in a second. Questions just come in about where the -3/2 and the 1/2 come from. So remember, A and B were -3/2 and 1/2, which if you took them out as factors, you can write that as -3/2 times 1/1 - 2x, or 1 - 2x to the -1. Does that make sense? So they're from your part A answer. That's how I knew that they were the values of A and B. So even if you'd got those wrong in part A and you carried on using that method, you would get followed through marks because you're doing the correct thing here, but you might just have those values wrong from the previous question. And it did say hence or otherwise. Okay, so they came from the previous bit, part A. Excellent, right. And then this one, we're going to do the same for this side of the expansion. So this is going to be 1, and then it's going to be, what have we got going on here? So we've got to kind of be careful with this bit. The -2 times -2x squared, and so on, and the same thing. And then what we do is when we tidy this up, expanding this all out and using your factorials, this will become -3/2 lots of 1 plus 2x plus 4x squared plus 8x cubed plus, and then this bit was, the factor was 1/2, 1 plus 4x plus 12x squared plus 32x cubed, and so on, all the way up. And it tidies up to, some of you might have got this, -1 minus x plus 0x squared plus 4x cubed. So that was a big extension on that question, but it was essentially doing two kind of binomial expansion parts to this. So the formula is in the formula book, as I said, I believe, but it's, again, building on partial fractions. So when you first meet this, perhaps at the start of year 13 or at the end of year 12, this bit almost seems a little bit out of place. It seems like a really maybe basic algebra skill, but it builds very quickly and suddenly gets quite involved. So we've done quite a lot there. If I just take you back through to recap all the different bits. So this one was a very straightforward, just do the partial fractions. Then we saw an improper case whereby we looked at kind of how the denominator could be manipulated to produce this value of A, and then we could just do the same method for partial fractions. Lovely, welcome back if you've rejoined. Then we used that answer to do an integration question, which is a big year 13 and year 12 topic. subbing in bounds and evaluating it as a number. Something as well our calculators can do and check, which is useful. And then we did another one with a repeated factor on the bottom, which we took on and did a binomial expansion of. I think, right, so that brings me to the next thing. So in answer to some of the questions that were coming in, I believe I've got another live stream on Wednesday, but we'll be going through different topics. Please do feel free to keep in the chat asking any bits about these topics, any questions at any point, if you need me to go back, if you need me to clarify anything, because hopefully that was really nice and clear. But there's so much breadth to this topic that it's sometimes quite tricky to do it. It's actually very easy to think you've covered it all. You know, I did a couple of questions out of the textbook and I get it. So that's it. I managed to do the hardest one. And people often think if they can do the last question, they can do them all. There's so much breadth to the A level that you have to do a kind of real honest approach at teasing out and finding the questions that really look a little bit quirky. So if you see a question and you think, no, I don't like the look of that, it's probably the question you should be practicing. And that's the kind of honest, independent approach we're kind of going for. And actually, with the way things are with schools at the moment, you may want the opportunity to talk through it. And that's what I'm going to get onto, because with the stuff Snap Revise are offering, we have drop-in sessions where if you want to ask me, directly a question, you can do that. And we also have previous web classes where students have asked questions and we've worked through them. And there's like a whole backlog of those that you can watch back over. So there's lots of live stuff all the time on the site. And so what I'll do, if I just stop sharing that there now, I'm going to just share my screen, hopefully on the correct thing. Please do let me know you can actually see the correct thing I'm trying to share with you here. So if you haven't been on it before, can we all see that? I hope so. I can't actually see your comments. So yeah, hopefully we can all see that. What we've got is on the Snap Revise site, if for example you go to the maths content, and there's so much on here, and I think you may well have seen this demonstration before, but all the topics are broken down. And for maths, it's brilliant because there is such a breadth to the course, and it might be just certain things you need to work on. So it's really important because you can kind of tailor your revision and your focus to exactly what you need. And sometimes it is just a little bit of snappy kind of, I need this sorted out and then I'm good. So for example, like logarithms, that's very much new in the sixth form. So you can kind of take the diagnostic quiz. I'm going to guess, I should know these answers, but we just rush through it. And that's maybe how some people do approach multiple choice. If it was me, you'd see I wouldn't be doing very well. So you answer the questions as best you can, give it a go, see what you get. Oh, I was right there. And if you run through the diagnostic quiz on logarithms, it really goes in depth. The stuff has been designed for the new A level. And I can't really stress enough how important that is. A lot of you, I'm sure, are really well resourced and good at looking online for questions on your topic. But sometimes the older syllabus material is actually not too good for the new A level because some of it's now redundant. There's other bits that have been added in since June 2017. So please do look at resources that are geared up for the new A level, because there is a difference. Now, what this does, it tells me is, you probably didn't get the score you wanted, but this is a topic that here are the bits you know, here are the bits you don't know as well. And so from there, you can kind of get started. And we've got all these videos that are broken down, and you can kind of jump to the key points. And they're done in a really sort of clear way with, excellent notes, excellent sort of points, and you can pick out exactly what you need to work through. There's also an exam pack. So these are, again, perfectly designed questions for the exam boards and the A-level exams under the new sort of framework. And you can view the solutions really clearly for any of these questions. You can do them easy, medium, difficult, and just kind of gradually progress up. And then also really lovely like revision guides that will hopefully load on all of these topics. Let me just try and refresh that. Oh no, that's not very good. I think that's me being slow here. Oh no, it's going really slow now. Okay, but yeah, revision guides on everything you can print off. It also tells you exactly what the specification is looking at. So really geared up for every topic in light of exactly how the examiners are going to look at it and what they're going to be expecting you to do. Also, if I just take you back to my kind of main page. So here we go. So what we've got as well going is the web classes. So there I am about to do some more web classes on Snap Revise. The timings, past recordings on all the different topics that you can go back and watch. And also drop-in service where you can talk to me about any questions you have on mechanics, statistics, or pure maths. So there's loads of them going on all the time, not just for maths, obviously. So loads on the Snap Revise site. I'd really encourage you to have a look at if you're finding this useful. I'm just going to stop sharing that there for a second. But as I said, we are running these YouTube sessions as well. So hopefully that's going to be quite useful for you. And I'll just return now back to my PowerPoint. And we'll run through some final kind of key bits. So if you found this useful, which hopefully you have, then feel free to obviously at this stage, keep checking because there's going to be another one on Wednesday, and maybe set a reminder, subscribe, and do also engage in the chat. It's been really useful for students who, have worked ahead of me at points, gone really quickly through this, managed to check their answers and also consolidate what they know, or maybe get an insight into the A-level as well. That's been brilliant. And the engagement, particularly at times where schools aren't on and, everyone's school and college is doing something completely different. Being able to actually engage, ask the questions, tease out, make the mistake, but learn from it, which we're all doing all the time, then please make sure you stay proactive, because it's a really weird, uncertain time. And as I said, there's going to be sessions in every day. So if you keep alert with them. In answer to that question that's just come in, there is actually a discount for those that have watched today. So here is a discount code for today. This is going to expire at midnight. So if you did want to sign up to the kind of fuller service that Snap Revise offers, with all the drop-in extras and the ability to be able to message the tutors directly and get some answers to your questions, there is the discount code. I think one of my colleagues has put that in the chat as well. So subscribe to Snap Revise. They're on, all the socials as well. So you can check out what's going on there. But as I said, loads going on YouTube. And I'm hoping this has been really useful for you because, as I said, it is very tricky not being able to engage in the normal way as you would normally in your lessons. But that's been brilliant. A big year 13 topic covered there today, but actually applicable to, year 12s as well. And even those that are maybe looking ahead in year 11 as a bit of an extension, you can see kind of where the maths you've learned is going to go and how involved it's going to become. It's a massive jump up from GCSE to A-level, one that we really can't underestimate, particularly in maths, but in all of your subjects. So yeah, as I said, the kind of extra service there that we're providing should hopefully be really useful for being able to tease out the things that, you just need to ask the question on. And for even, the most studious among us that really feel confident with the content, there will always inevitably be the odd bit that we want to challenge or check or really just tease out and go over, and that can kind of be achieved with the engagement online. So as I said, there will be more on YouTube every day. There's more today even. So if you want to keep checking out what's on over the next few days, that would be brilliant. But as I said, I'll be doing a lot more on Snap Revise. So feel free if you have enjoyed this and you would like to sign up to do that. And I will be back on Wednesday to do another session. So I'm going to stop sharing that there. Thank you all again for taking part really well in that. That was a big topic, and some of you just sped through it, you know, well ahead of me at a brilliant pace. So that was brilliant. Keep well, take care, and hopefully see you at a later stage on another YouTube live stream. Thanks very much. Well done, guys. And I'm going to end that there. Okay, so I'll be back on Wednesday and hopefully see you then.